Hi everyone, and welcome to the course Machine Learning 1 Understanding the Foundations of Pattern Recognition and Machine Learning ML1. My name is Deepak Gupta and I am an adjunct professor at Indian Institute of Technology, Dhanbad. This course is a part of the academic curriculum for the students at IIT Dhanbad and it has been designed as part of the skill development program by Techsmin Foundation at the institute. This is week 1 of the course and I will be covering 2 modules in this week. In the first module, we are going to get an overview of the course itself. And in the second module, I'm going to walk through some basic concepts of machine learning. So diving into the first module, Introduction to ML1. So we will go through some basics of the course itself, how the course is designed, what are the should be the expectations from the course, what are prerequisites, and how will the course run in the next few weeks. So this is an outline of what I'm going to discuss about the course. We'll provide an overview of the course itself, the what to expect prerequisites, some content of the course lectures, the guest lectures, the capstone project that becomes the final step of the course, then a poster presentation session, and roughly how the grading or evaluation will happen for the students at the institute. For those who are attending this outside the institute, there will be some parts which are not relevant, so please skip them. So, ML1 is designed to provide a detailed overview of the various concepts in the fields of pattern recognition and machine learning. The course itself has 4 important parts: the course lectures, the checkpoint, quizzes, the capstone project, and then the final evaluation during the poster presentation. So the course lectures comprises of a total of 11 weeks of lectures. Week 1 is basically what we are doing now. So it covers the course overview itself, basics of machine learning, and then there will be 10 weeks of main course. There will be 2 assignments or quizzes which will be given as part of the course, and these will be used for final assessment. There will be a capstone project which will run in parallel to the course. So the students will be divided in batches of 2 to 5. Each group will work with a mentor, and they will need to work on an AI project for around roughly 3 months, and then they need to compile a short paper out of it. This short paper will also form a part of the assessment. Finally, the report will be graded, and there will also be a virtual poster session where all the groups will present their work. That will conclude this course. Now, what to expect from the course? By the end of this course, it is expected that you understand why certain things in ML happen when they actually happen. I'm pretty sure that most of you now have some experience with implementing some machine learning methods. You can find nice codes online, just clone from GitHub, run them, and then you see the magic of machine learning. But that is not what you should expect. What this course expects from you is that you do stop treating machine learning as magic. You have to start understanding what's going on behind the method itself. So the first important step from this course, the first takeaway from this course is that you start treating ML as maths and not magic. The course will have a strong focus on fundamentals and principles of machine learning. It will explain concepts such as Bayesian learning, generative models, etc. I'm pretty sure that most of you, although you have some experience with machine learning, you might not be aware of some popular terms like KL divergence, variational inference. But believe me, these are some very important concepts in the field of machine learning. And by the end of this course, what I expect is that you understand these concepts. So I have this picture below, which tries to explain the transformation that you can expect from the course. So expect that right now you are on the left side of this, on the picture. So you right now treat machine learning as magic, and you can do fancy stuff with nice code on GitHub with maybe small modifications. But what this course wants you to become is what you see on the right side. It wants you to become the thinkers of machine learning. You start thinking why things are happening the way they are happening. If I'm giving you 2 algorithms, algorithm A and algorithm B, if B performs better than A, then I do not really want you to report me the numbers of A and B. What I want you is basically to understand why B is doing better than A. So that is more or less the motivation and the expectation behind this course. Now, coming to the prerequisites for the course, it is mandatory that you understand the basic concepts of multivariate calculus and linear algebra. Rest, I think we will learn on the way. Calculus and linear algebra form the foundation of most of the strong concepts of mathematics, and machine learning is no exception. If you know these two topics very well, learning machine learning will just be a piece of cake. It's going to be super simple. You just need to ensure that you have knowledge of machine learning. You have the knowledge of multivariate calculus and linear algebra. Knowledge of some basic ML concepts is recommended. If you do not have some prior experience with machine learning, it's still okay. But what I then expect is that after we go through the second module of this course, where we get a high level introduction to machine learning, the topics that we go through in there, I would recommend looking at some online material, trying to also do some extra study outside this course to keep yourself at the pace throughout the all the lectures. Now, some basic concepts of probability and statistics would be really helpful. Some recommended open material is I would recommend check out the free courses on descriptive and inferential statistics at Coursera, Khan Academy, Udacity, Udemy, EDX, etc. For basic concepts of ML, see the machine learning course by Professor Andrew Ng on Coursera. Believe me, I think most of you know this course, but this is the course with which I also started to learn machine learning. Now, this is roughly the content of the course lectures. It might get adapted as the course runs, but overall, this course is basically inspired from the book Pattern Recognition and Machine Learning by Christopher Bishop. This is a really nice book. If you want to do some extra study outside the course lectures, just this book I would strongly recommend, because these lectures are basically based on the content of the book. So the course is going to comprise to run for a span of 11 weeks, and in week 1, where we are right now, this is basically the introduction to ML1, and we also have machine learning overview of basic concepts, and then the rest of the weeks you can see the content. I'm not going to read each of these, but you can roughly see that we are going to go through probability theory, probability distributions, uh, deep theory of linear regression, classification, neural networks, kernel methods, graph models, sampling methods. So there are a lot of concepts, and I'm pretty sure there is a lot to learn here. So I guess it is going to be quite intense, but I think it's also going to be fun. Apart from the main lectures, we are also planning to have 5 to 7 guest lectures in this course. And these guest lectures will roughly be spaced after every 2 course lectures. Each guest lecture is supposed to be of 60 minutes with a break of 10 minutes in between. And these guest lectures will also be recorded, and they will also be posted on our course website. And what we expect from the guest lectures is that each guest lecture is going to explain some certain subfield within the field of AI, as well as its applications. The planned lectures are right now, it's AI for neuroscience, graph neural networks, AI in exploration and mining, variational inference, and we're also on the way of deciding more lectures. But what the idea is to, apart from the course lectures where we try to understand the maths behind machine learning, these guest lectures are basically going to give you a flavor of some special subfield of machine learning, for example, graph neural networks. So if you want to really understand the basics of graph neural networks, how the field has developed, how you can really dive into the field, what would be the relevant study material. So this guest lectures are going to give you the basics of certain subfield, and apart from these guest lectures are going to be from experts who are working on these topics on in some reputed research centers or institutes across the world. And what we'll also try to do is for the students at the institute, we are also going to have 15 minutes sessions in a groups of 2 with the guest lecturers to just get a 1-to-1 or 2 students to 1 conversation on how to really do research in an academic setting. Now, coming to the Capstone project and poster presentation, the Capstone project provides experience working in a team on exciting AI topics with some supervision from experienced mentors. The duration of each Capstone project will be roughly 2 to 3 months, and each group is going to be 3 to 5 students. So I know there are a lot of students who are purely starters in machine learning. For them, what we are planning to do is to have capstone projects where they're going to work on well established machine learning or data science problems such as Boston housing prices and this classification, and we will try to accommodate all the students. So basically on these simple projects we are going to give minimal supervision because there's a lot of material available online, but we will have a very clear problem formulation for each group. For students with some experience, we will be conducting projects related to the running Kaggle challenges as well as tailored projects from the mentors. And these capstone projects are also only for the institute students at the institute. So further details related to the capstone projects will be shared through the Google Classroom platform. For the students will be generally meant for every capstone project, the students will be mentored by one or more experienced professionals, and then they have to draft a short report of 4 to 5 pages. If the work becomes good, something good comes out of it, and the students want to write a paper, it's totally at the discretion of the students and the mentors what they want to do with it. What we expect is that you submit a nice report, you do some nice work during your 2 to 3 months, you submit a nice report, and then we want to see you at the virtual poster session where there will be a lot. We expect a lot of people to look at your work, ask good questions, and then that would be the final session for the course. The final evaluation will be on 4 different aspects. The quizzes assignments, they are going to comprise 40%. The structure of the quizzes might vary from simple questions to doing theoretical derivations as well. There will be a capstone project which is going to be graded for 40%. The poster presentation, how you present your work, how you communicate your machine learning findings, that will be 20%. And then during the course lectures, we will have in-class bonus assignments that will be 10%. So let me tell you that these apart from these videos being recorded, I also am conducting the live lectures for the class, although in a virtual platform. And these in-class bonus assignments are going to be during those live lectures and not here. If you're also watching this course from outside the institute and you are interested to also look at these capstone projects and the in-class bonus assignments, they will be posted on the website. So take a look. Now, it's also important that to successfully run a course, we have some honor code. And for this one, it's going to be quite simple. This course is purely meant for learning and does not affect your grades, even if you're part of the institute. This course will have a grade on its own, a certification, but it will not affect the final grade that you get when you graduate. I would recommend discuss with others, but try to formulate your own solution to quizzes and assignments. Let's be friendly to the other classmates and the course staff. Be polite in your questions to the teacher and the TA. No one is perfect. We can also commit errors. You are learning in terms of basically learning new concepts of machine learning. We are learning to communicate these things to you. So everybody is in a phase of learning. So let's be polite to everybody. Even then, if you have any complaints, just write to me at this email and I will act accordingly, maintaining full privacy of your identity. Lastly, the additional information related to the course. All course material will be made publicly available. So whenever you are watching the course, during the live lectures, no need to spend time making notes or recording a live session. Make sure that you are able to extract as much learning as possible and try to use the extra available time. If you have any questions, just ask during the lectures themselves. Put your focus on learning. That's the whole idea. Now, accessing the course slides, links to course videos, assignments, quizzes, and any additional material. This is the link to the course. All the material can be accessed here. All the videos will be available at the YouTube channel of Transmute AI Lab. So Transmute AI Lab is basically our virtual lab. And this is the link to our YouTube channel where we'll be posting all the videos. And I mean, it's a lot of work. We are conducting these lectures live in the class, and then we again have to record. So expect that the final videos will be uploaded on YouTube with a delay of 1 to 2 weeks, because we are a small team. We are working hard to get everything out to you. So apologies for any delay. Lastly, we do some awesome research as well. So if you're interested in following our research, look at the website www.transmute.ai, and also follow our LinkedIn page. So that's all for today, for module 1.